Alright, so let's continue with the rest of the section. It says find the x-coordinate of each local minimum and local maximum in each function. Justify your answer. So let's go ahead and take this derivative. And if you notice, I have the quotient rule. So I get f prime of x is equal to the bottom times the derivative of the top, 3x squared, minus the top times the derivative of the bottom, all over the bottom squared. So let's go ahead and simplify this. We get x squared minus 3 times 3x squared minus 2x to the fourth, all over x squared minus 3 squared. Let's continue to simplify this. And if you take a look, we get 3x squared times x squared minus 3. If you notice, I can factor out an x squared from each of these. And what I get is x squared times 3 times x squared minus 3 minus 2x squared all over x squared minus 3 squared. If I simplify it a little bit more, what I get is x squared times 3x squared minus 9 minus 2x squared all over x squared minus 3 squared. And if we continue, I get x squared times x squared minus 9 all over x squared minus 3 squared. So what I'm going to do is set these equal to 0 and see what happens. If I set the numerator equal to 0, my derivative is equal to 0. If I set the denominator equal to 0, then my derivative is undefined. So let's take these pieces, and I get x squared is equal to 0, x squared minus 9 is equal to 0, and I get x squared minus 3 is equal to 0. Minus 3 is equal to 0. So I get x is equal to 0, x squared is equal to 9. If I square root those, I get x is equal to positive minus 3. Over here, that's a minus sign, so I get x squared is equal to 3. Square root those, and I get x is equal to plus or minus radical 3. Okay. So let's go ahead and take a look at what this means. I'm going to draw my number line, making sure it's all right. Okay, so here's my number line. And what I'm going to do is to pick points that will fit on here. So first, let's put our critical points in order and see what happens. Let me extend this because we have 5 critical points here. So, okay, that's better. So I put these in order. I'm going to get a negative 3, then I get a negative radical 3, 0, positive radical 3, and positive 3. So what's important is to take a look at this derivative. And just to remember, our derivative was equal to x squared times x squared minus 9 over x squared minus 3 squared. So let's go ahead and pick some test points. Okay, so let's pick negative 4, negative 2, negative 1, positive 1, 2, and positive 4. And what we do know is my numerator was equal to 0 here, here, and here. My denominator was equal to 0 at negative and positive radical 3, so I know these are undefined. So let's take a look at what happens to this fraction as we're going through it. And if you notice, let's do them right here. I have fractions for my denominator. And if the bottom is always squared, doesn't that mean that the bottom is always going to be positive? So I'm not going to worry about the denominator right now. All I'm going to worry about is the numerator to see how that's going to change its values. If I were to plug in a negative 4, I would get positive 16 times 16 minus 9, so that gives me a positive value. So I know over here, my derivatives are all positive. If I were to put in a negative 2, I get a negative 2 squared is positive 4. Negative 2 squared is positive 4 minus 9. That gives me a negative value up here. If I plug in a negative 1, you'll see that will also give me a negative value. A positive 1 will give me a negative value, and a positive 2 will give me a negative value. But a positive 4 will give me a positive value. So negative over positive is going to give me negative. Same thing here, negative over positive is negative. Same thing here, these are all negative. This will also be negative, but this right here will be positive. So if I were to write these down, I'm increasing, decreasing, 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 and increasing. So if I were to draw those out, I would have something that's increasing, decreasing, 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 and increasing right here. So all the question is asking for the x-coordinate of a local minimum and the local maximum. This point right here is a high point. This point right here is a low point. So let's go ahead and do this. This is happening when x is equal to negative 3. This is happening when x is equal to positive 3. So my maximum is when x is equal to negative 3. My minimum is when x is equal to when x is equal to positive 3. And there's your answer. Alright, let's take a look at the last problem in this section. And if you notice, this is going to use the product rule. So let me rewrite this to make it easier on our eyes. This is equal to x times 9 minus 2x to the 1/2. Right? Let's take the derivative. G prime of x is equal to the first term times the derivative of the second. So first term times 1/2 times 9 minus 2x to the negative 1/2 times negative 2x. Oh, sorry. Times 2x to the negative 1/2. Let me make something for this. Okay, times I need the derivative of the inside, and so the derivative of the inside is negative 2, plus the second term, 9 minus 2x to the 1/2, times the derivative of the first, which is just 1. So if I simplify this, this 2 cancels this 2, and what I get is negative x times 9 minus 2x to the negative 1/2 plus 9 minus 2x to the 1/2. So let's go ahead and bring down my denominators, and what I get is negative x divided by 9 minus 2x, and it's a 1/2, so I know it's a radical right here, plus, and I get a radical 9 minus 2x to the 1 minus 2x. So if you notice, I need common denominators, so what I'm going to do is multiply this side by radical 9 minus 2x, radical 9 minus 2x, and that's going to give me negative x. This radical and that radical cancels to give us 9 minus 2x all over radical 9 minus 2x. And if I simplify, I get 9 minus 3x all over radical 9 minus 2x. So let's set these both equal to 0. And do this on another page. Oops. Right here. So here's my derivative. Let me just make sure we label that our derivative. F prime of x is equal to this. So I set the top equal to 0. And I also set the bottom equal to 0. I don't need that radical because that's just going to square things, right? So I get 9 is equal to 3x. X is equal to 3. 9 is equal to 2x. X is equal to 9 over 2. So let's go ahead and draw our number line. And what I'm going to do is make this a little bit smaller just so we can see everything. Alright, so let's do a number line right here. And I have two critical points. The smaller one is my 3. And the bigger one is my 9 over 2. So let's test some easy test points. Let's test 0. Let's also test a 4 and 5. Alright, so let's take a look and see what happens. I know my derivative occurs when the numerator is 0, my x is equal to 0. The denominator is 0, my x is equal to 9 halves. So let's test these points. If I plug in 0, on the top, I'm going to get a positive. On the bottom, I'm also going to get a positive number. If I plug in 4 on the top, I'm going to get a negative. On the bottom, I'm going to get a positive number. When I plug in 5 on the top, I'm going to get a negative. And on the bottom, if you notice, 9 minus 10 is equal to negative 1. But I can't square root a negative number, so this right here will be a D and E. So a positive or a positive gives me positive values. Negative over negative, oh my apologies, this bottom part would give me a positive value. But a negative or a positive gives me negatives. And this right here we said is it does not exist. So if I were to interpret this as increasing or decreasing, this is increasing, this is decreasing, and this is no information. So if I sketch this, I get up and a down, and that gives me a maximum when x is equal to 3. And to justify this, I'm going to say there's a maximum when x is equal to 3, since f prime of x changes from positive to negative. And that's enough to justify the maximum. That's the end of this section, so good luck with that, and I'll give you a couple problems in a minute. Thank you.